We can probably go ahead and get started. So my name is Alicia Gavin. I work as the Digital Outreach and Design Specialist here at RoboNation. We're really excited to welcome back Mathworks for our mini series. Last year, we did a 3-part series that you can find on our YouTube channel. And this year, we're doing another 3-part series. So today we have Cornel D'Souza here from Mathworks. So we're really excited to have him, and I will go ahead and turn it over to him.
All right. Thank you, Alicia, for that very kind introduction. While I share my screen real quick, I'd like to thank everyone for coming out here. I think it's great that you all are interested in using MATLAB tools, and we're here to help. We've been sponsors of RoboNation for, I want to say, a few years now. I don't remember how long, but it's been a long time. Definitely as long as I've been working in the Mathworks, which is the last few years. So thank you so much for taking the time. I see a few familiar faces in the audience. Professor Dave, hello, nice to meet you again. We haven't chatted in a while, but it's nice to see you. And Eric Coyle, nice to see you as well. All right, so without wasting too much time, I'm going to go in. I don't have any software demos for you today for the primary reason that ROS is a little finicky to use, especially when you're trying to share a screen over an internet connection that's also going to be using that ROS is also going to be working on. So I've got a bunch of screen recordings in my slides, as well as links to examples. We can share the slide deck with you all after the fact. But y'all can also just go onto our documentation page and take a look at all the examples that we've got. So yeah, without wasting too much time, let's get started. Let's jump right in. So for today's agenda, we're going to cover a few different things. We're going to talk a little bit about what ROS capabilities we have from MATLAB and Simulink, and then talk about a typical either ROS or ROS2 workflow. If you all have used MATLAB and ROS in the past, you notice that ROS2 is kind of new for us. We've ramped up our support for ROS2 over the last couple of releases. I think the plan is that maybe either within the next release or the release after that. So hopefully by 23B, which should come out in October, we should have full parity between ROS and ROS2. So whatever you're doing in ROS right now, you should also be able to do it in ROS2. We'll talk a little bit about some ROS and ROS2 application examples, and then we just do a quick summary and some key takeaways. If you have any questions, please feel free to pop it in the chat. I'll try and stop and answer questions as and when I can. But if not, at the end, we can definitely have a chat about any questions that you might have. All right, so let's jump right into some of the ROS capabilities from MATLAB and Simulink. Okay, so it's essentially with ROS, you're primarily trying to do 3 kinds of things, right? You're trying to connect to a network and communicate with the different ROS nodes in the network. So that's something that's possible from MATLAB and Simulink. You have live connectivity to both ROS and ROS2. There are a number of examples that are very simple and very easy to run. You can take a look at in our documentation. We've got connections to simulators like Gazebo. So if you see those 2 examples on the right, we ship a virtual machine with the product. So if you're interested in, as long as you have some kind of virtual machine, you should be able to run all these examples straight out of the box. Excuse me. The next item of support that we have is we've got support for a number of types of ROS messages. So you can do things like ROS bag read and write, as well as playback. So one example of this is if you run a particular simulation and you want to analyze after the fact, how does your system perform? How does your simulation work? You essentially save your simulation as a ROS bag, and then it's a 1-line command in MATLAB to replay that, or to load the data in and replay the ROS bag. So if you see those little examples on the side, that's a little turtle bot moving around someone's office, and you can capture information like camera, or laser or whatever other sensors you've got on there. We've also got some support for specialized ROS messages, so things like images, laser scans, point clouds, Velodyne lidars. Again, all things that are something that you all will use on a day-to-day basis in the RoboNation competitions. And the last sort of workflow activity is ROS node generation. So from MATLAB and Simulink, because we've got the ability to generate code, you can essentially generate standalone ROS nodes that run irrespective of MATLAB. So, we often hear, you often hear people say that, oh, MATLAB's kind of slow. There's a reason. MATLAB is an interpreted language. But when you want to move into a production environment, or you want to move the code onto your robot, you don't have to have MATLAB in the loop. You can essentially generate C++ ROS nodes that run independent of MATLAB and a lot quicker. And the idea is that you're following a process called model-based design, where you use MATLAB and Simulink to prototype and test your algorithms. Once you're ready, you hit a button and generate ROS nodes from there. And there are a number of examples on how you could do that as well. All right, so let's take a look at those three typical workflows that we just spoke about, right? So in a traditional ROS environment, or in a traditional robotics development cycle, MATLAB and Simulink sort of sits on the left-hand side, as you see, where you're trying to do things like perception, planning, controls, decision making, logic, etc. And you're typically working on some kind of, either a Windows or Mac or a Linux environment, and MATLAB is one of the tools that can help you do that. There are obviously other languages and other tools available, but I'm going to keep it to the realm of MATLAB and Simulink for now. On the right-hand side, you have your ROS environment, and ROS, as we know, is typically Linux-based. I know ROS2 is works on both Windows and Linux, but ROS has typically been Linux-based. But in that realm, you connect to things like the Gazebo simulator, or you connect to a ROS-enabled robot. We've got an example of a TurtleBot up there, or that may be the WaffleBot, one of the generations of TurtleBot that has various sensors and things like that. And then you're either doing one of two things. You're either connecting to that ROS network and interacting with it in the sense that you're getting back information or you're feeding commands in, or you're also connecting with these little isolated ROS nodes that help you decentralize your process and speed it up. And then lastly, if you want to run some kind of if you want to sort of analyze how your simulation went, you save it all as a ROS bag and analyze it after the fact. But with MATLAB and Simulink, you're essentially able to connect ROS and MATLAB while still working in whatever environment you are. So if you're on a Mac or a Windows computer or a Linux computer, you can do all of that. You can essentially connect to ROS and spawn up your networks and interact with it all from the same computer. You don't have to move over to a Linux environment. We tend to use this with the virtual machine for demonstration purposes, but you can essentially spawn up a ROS node on your MATLAB enabled Windows computer, right? So the first workflow that we're going to talk about is offline analysis, or ROS bag import, right? The second one is actually being able to connect. So you can connect to the ROS network in real time. And this is really useful with prototyping, because if you've got a robot sitting next to you and you want to see what a particular kind of sensor data looks like, there are single line commands that you can just subscribe to that particular topic and pull that data into MATLAB in real time. And the last workflow is the ROS node generation, or the deployment workflow, which is you've prototyped your system, you know how it works, you're happy with the way it works. Now you want to put it into production. So you generate a node that's in C or C++, and it's running independent of MATLAB. So you don't have all the overhead of actually running MATLAB in the loop as well. So the code's a lot quicker. So let's do a little bit of a deep dive and see what it looks like to run some offline analysis in MATLAB. So you can connect to a ROS bag from both MATLAB and Simulink. As you see, it's a single line, bag equals ROS bag, and then whatever your bag file is. But then with that, you can land up selecting specific messages, reading them, and also once you pull the message into MATLAB as MATLAB data types, you're essentially open to any kind of analysis that you'd already do with MATLAB. With Simulink, it's the same way. It's just blocks instead of code. So as you can see, we've got a ROS bag block in Simulink where you feed in the name of your bag file, and then you can essentially create that same code, but just in the form of Simulink blocks. So again, a pretty simple, pretty easy to get started. You can also extract them as a time series, so play them like the actual simulations happening, or dig into specific messages and try and synchronize and visualize them individually. So the options are pretty endless once you pull the ROS back into MATLAB. So let's see what it looks like when it's working. So on the top right hand side, we've got we're essentially reading a laser scan message from a simulation run of a little robot running through our offices here in Natick. But the top is MATLAB. There are codes, there are lines of code that's available. This is also an example. So as you can see, you have access to every sensor message that you're looking for in there. On the bottom, again, what the Simulink model showed you was essentially, I believe it's IMU data from a robot run. Again, reading off that ROS back block and visualizing it. So as we said, import it, but you can also select what you want to play and play it back. Similar functionality works with ROS2 as well. It's just the name of the function is different. We also have, and this is this is some new functionality that we've added in 22B, which was the last release that came out a few months ago. So you can now also write to a ROS back, right? So it's essentially you create a simulation. You're trying to record data. One good use case, as you can see on the right, is it's a self-driving car trying to navigate through a world. We've seen a lot of our customers use this to generate training data. So if you want to create like camera data for you to train your networks and so on and so forth, you essentially drive your robot through the world. But at the same time, you're logging all your sensor information, so you can use it after the fact to create your algorithms with actual real life data, right? So in terms of feature parity, we've got from MATLAB you can from MATLAB and Simulink you can write and record ROS bag information. As of today, for ROS2, you can only do it from MATLAB, but we've got that feature coming out for Simulink in the future, hopefully in the next couple of releases. So from MATLAB, essentially what you do is you just call that ROS2 bag writer function, and it'll help you save your information as a bag file. And as I said earlier, you can work with different kinds of messages for ROS2, both standard or custom messages that you create. There could be an option where you find that a standard message is probably beaming out too much information and you don't need as much of it. There are ways in which you can create a custom message so to make sure your system's performance is a little better. But then you can also write single records or multiple records as you want. We've got some new functionality in 22B called the ROS Logger app. This is an app within Simulink. So if you're running a particular Simulink simulation, you can use the ROS Logger app to essentially select what messages you want to save. And then the advantage of doing this is once you turn the app on and you select what you want to save, once your simulation is run, it'll automatically save the ROS bag file into your current folder. So the advantage of this is, if someone has a more powerful computer, say with a GPU, you essentially run that, save it as a ROS bag, and you can hand it over to other people so they can work on their laptops and not have to have the overhead of running a full simulation with a gaming engine or something like that. So again, a couple of examples here. I'll share the slides with RoboNation later, and they can pass it on to you all. But essentially, there are some examples that you can take a look at in the documentation that can help you get started. So these are some examples that we've got that are specific to ROS bags and creating ROS bags and reading data from there, playing it in real time, and so on and so forth. I'll leave it to you all to go and take a look at these after the fact. But if you have any questions, you can always reach out to us. We're happy to help you out. Okay. So let's get to the second piece of the workflow, right? The second piece of the workflow is that live connectivity of being able to connect to your ROS network in real time. Okay, so this is an example. If you've used ROS at all, you're familiar with ROS init and ROS topic list and all these kind of functions. There are very similar functions in MATLAB to that. So essentially, in MATLAB, you say ROS init space your IP address, it'll spawn up a ROS node right there, or a ROS master, depending on if you're connecting to a network or you're just trying to initialize a global node, right? But what we have here is this Sawyer robot. It's a robotic arm in the Gazebo world, and where as long as we have that same IP address between Gazebo and MATLAB, we're able to essentially get every ROS message that's beaming off of that Gazebo simulator. We can also use functions like the ROS publisher, so ROS publisher and ROS subscriber, and that'll help you either publish messages to the ROS network or subscribe messages from the ROS network. So as you can see, very couple lines of code, you're able to get data and get started. We've got similar functionality with ROS2 as well. So this is the Simulink version of that. Like we have ROS subscriber functions in MATLAB, we've got ROS subscriber and ROS publisher blocks, which again they're both different flavors depending on whether you want to use MATLAB or Simulink. I am personally a bigger fan of Simulink just because I don't like to write a lot of code. I like to drag and drop things. But again, people have different preferences. So whatever floats your boat, we've got you covered on both ends. Okay, so we have some templates set up for both ROS and ROS2. So your typical robotic system is essentially you do some kind of setup. You are sensing in some way, depending on whether you've got cameras, lidars, IMUs, a whole host of sensors. You run some process, you process that sensor data a little bit, and then essentially come up with control commands or control instructions for your system. And then finally, you may want to visualize. If you're more in the prototyping stage, you're trying to visualize the information. But if not, and your codes are ready to go, you're just trying to essentially feed that into a loop. So how do you connect to ROS from MATLAB? It's essentially ROS init with the IP address, followed by so the setup stage is obviously connecting to the ROS network. In ROS, it's ROS init. In ROS2, you essentially just create nodes. So you say ROS2 node, and then you give in the node name and the domain ID. Next is sensing. So essentially what you're doing when you're trying to sense or when you're trying to pull that sensor data in is you're trying to either subscribe to a topic that's beaming out sensor messages or publish. So in this case, we're essentially trying to publish some kind of velocity command, right? But that's how the sensing piece of this works. Then you put it into the loop, and this is where you've got the sensor information. Now you're going to take that information, either process it. If you're using like a lidar, you want to downsample, you want to perform some operations on it, and then compute control commands. And essentially, once you've computed the control command, you use the send function to publish whatever values you've computed back into the ROS network. And then if you want to visualize it, you can use all of MATLAB's plotting capabilities to do that, right? With Simulink, it's the same way. As I said, we've got you set up this. In Simulink, the way it works is you set up a bunch of options. So as soon as you hit run in the model, all of that initialization of it all happens under the hood. That's the way we've set that up, right? Again, sensing you're subscribing to different topics. Simulink is great because you can handle different rates. So typically, if you've got 3 or 4 or multiple sensors, they're not all sampling data the same rate. Simulink makes it really easy to handle data that's sampled at different rates to ensure that you always have the most that you have integrity in your data, and you're not getting data hits from different time steps, which can make your robot do weird things. Simulink is I like to say Simulink crunches or eats numerical equations or differential equations for breakfast, because it's one of the best control tools, best tools out there for making for developing control algorithms. So um, you know, you've got the power of Simulink at your fingertips, and then essentially uh, package up all that information into ROS messages that you can send out to the network. Again, these are either some of the specialized messages that you have, or custom messages that you've created on your own, or just messages that are available in your network. Yeah. So working with some ROS specialized messages, right? So if you've got specialized sensors that have ROS network or ROS messages available, you can integrate that into your code as well. We've already got built-in support for images, laser scans, point clouds, Velodyne lidars, occupancy maps, etc. With also the ability for you to add custom messages to your network as well. And there's a link to that which y'all can take a look at once this is over. So here are some examples that you can that you can look through. Again, we've got a lot of examples with the TurtleBot, where if you're new to robotics and trying to get started, that's a great place to start, because you've got a nice sensor, a nice robot in a virtual world that has a bunch of sensors on it that you can pull the data in and try cool things with it, right? But we also got some getting started for both ROS and ROS2, and most of this functionality that I've spoken about is available with both ROS and ROS2. They're just different blocks for it. We've also got some examples on ROS custom messages. So as I said earlier, if you feel like whatever message is in your ROS network, or if you've developed a custom message for your robot, there are ways to pull that into MATLAB, and there's an example of how you can do that, as well as working with more specialized messages like the Velodyne ROS messages, or some other sensor that you might be working with, right? Okay, so the third piece of the workflow that we want to talk about is deployment. Hopefully, if anyone has any questions, please feel free to pop into the chat. I can stop and take questions at any time. But the third sort of workflow piece in this is deployment and ROS node generation, which again I've spoken about a little bit, but we can go into a little more detail. Second. Okay, so there are two cases in which you'd want to generate ROS nodes, right? The first one is where you just want to sort of generate a ROS node on your local computer or your development computer, right? And in Simulink, there are two ways to do this. So there's one called the build model option, and then the build and run option. So what these do is, once you hit build model, it'll essentially generate a ROS node locally on your host, and it'll also compile it. So the ROS node will run on your local computer, but it's running without MATLAB. But you can still interact with it from MATLAB, but the node itself is running standalone. The build model option will not trigger the node to run. It will just compile it and keep it in your. So you can go in and manually fire the node up. But if you click on the build and run option, it'll do the same thing and then start running the node as well. So when are some cases when you might want to do this? Either you're working with a system where you want to generate a ROS node, but then manually take that over onto your robot, right, or onto your system, or you don't necessarily want to configure the setup of your system or the ROS device, so you want to do that later. This is a good option for you to generate these nodes. Another use case could be like, say, because ROS is such a decentralized system and a decentralized messaging service. Your robot may not be the best place to run something because you're either running short of battery, or you have other constraints in mind. But you've got more powerful development computers where you can run some of your more complicated, complicated pieces of algorithms. Say if you're running some complicated deep learning, again, there are reasons why you'd run it on on the robot and reasons why you run it away. But this is an option that can help you do that and help you accelerate the way your code runs. The next option for you is to actually deploy these nodes directly to the remote device, right? So say you've got a computer running on your robot, you want to run the ROS node there. Again, we've got the build model option, which will generate the C++ ROS node. And this is a use case when you can just click on that build model button, because you don't know the configuration of or setup of your ROS device, or you have other nodes to build. This is just the one single node that you're working with, and you want to build them all together later. So that's one option. If you choose the build and load button, it'll essentially generate the C++ ROS node to the ROS device. And then it'll copy the source folder to the workspace, and then it'll run catkin or colcon build. This is typically useful when you're trying to build a number of nodes together. But your robot is not yet configured to run the ROS node yet. The last option is, again, build and run, as everything that we've described earlier, but it'll launch the node as well, right? And this is when you want to use this in the case when you want to run a standalone ROS node without connecting to the host. Okay, so some options available. The good thing about this is every time you want to make a change in the algorithm, and this is where the power of model-based design comes in. Every time you want to make a change in the algorithm, you don't have to go through all the C code. You just go back up to your Simulink model or your MATLAB code. Make that change in the high-level language that helps you not have to deal with so many lines of code, and then essentially hit one of these options again and rebuild, right? So this is it helps to program in a high-level language and then run code in a low-level language, because you're spending less time debugging and you're not accidentally introducing more errors, because that's what happens with your debug. You leave a semicolon off somewhere, you make a change somewhere and don't realize it because there's so many lines of code. You tend to get lost in the sauce, as you call it. But it's nice to program in a high level language and then essentially generate nodes from there. Eric has a question. From past coding experiences, sometimes things run in MATLAB but can't. Is there a reference list of what is and isn't able to be? Yes. So we do have a doc link somewhere. From what I know, everything that's code generable will generate a ROS node for it. So as long as your code is, and we have a list of things that are, we have a list of functions that are code generable and functions that are not code generable. But as long as your code is code generable, you should be able to generate ROS nodes from it. But if you have a hard time, please reach out. We can try and help you out with that. I can send you a link to the list of functions that are code general and not. Okay, so how do you work with this generated ROS node? So you've created a node. It's running in your network. There are essentially three ways to do it. One is where you use the ROS device object. So when you're using the ROS device object, as your system's running, you can essentially spawn up a MATLAB node or a Simulink node within your on your computer that helps you monitor things, right? So you can subscribe to whatever messages you want to and publish to whatever message publish to whatever topics you want to as well. So that's one way of using the generated ROS node. The second way is to use something called the ROS parameter server. So essentially you can publish and you can essentially publish updates to the parameter server that your ROS network will then use to run your code. And the third thing is actually something that's one of my favorite things about Simulink, is this thing called external mode, which is where within Simulink you're able to interact with whatever code that's running in your ROS network. So you could think of things like changing parameter gains, changing sending waypoints. There are a whole lot of things that you can do, but you're actually viewing it in real time as it's happening. So external mode is a pretty powerful feature of Simulink. So we'll take a little time to go into this in a little bit of detail. So first, let's take a look at the ROS device object. So essentially what it does is it creates a connection to your ROS device. And this could be, your ROS device could be running on a local, on your local computer or on the robot in a remote capacity. But you're essentially able to create a live connection with that in real time. But you can do things like running your ROS course, starting it up, closing it down, and essentially manage your ROS network from within MATLAB itself. And you can also do things like check the status of it as well. And the way to do this is, again, pretty simple. You create the IP address, use the ROS device function, and you can monitor things like what are your available nodes, which nodes are running, start at the node, kill the node, different things like that. The next piece that we talk about that we spoke about was the let me just get rid of this. But the next piece that we spoke about is the ROS param utility to communicate with the generated node. So this is at runtime. You can use things like list, get, set, and delete ROS parameters. Again, single line MATLAB commands, and this will help you work with ROS namespaces as dictionaries. So as you can see, this is a little it's a little list of the ROS param list, different sort of commands that you can use to interact with the generated ROS node. And then the third piece that I spoke about is external mode. So with external mode, you're communicating with the deployed ROS node on your robotics hardware during runtime from the host. So it's essentially a TCP/IP connection that's made between Simulink and the ROS network. And you can tune your parameters, visualize your signals in real time while the ROS node is running. So this is not something that you want to use in a production environment. This is more of external mode is more of something that you're using while you're developing your code, while you're trying to make tweaks to it. You probably want to use one of the other methods, because you can essentially build an app in MATLAB that's subscribing to these messages, and that becomes your dashboard, right? You can feed in all the information. So external mode is probably not a good option at that point, but it's something that you want to use when you're developing your code and trying to prototype things. But essentially, as you can see, they've got some dashboard scopes as well that they're using to pipe that information in over TCP/IP, and you can visualize different things that you want from your ROS network. Okay, this is some new functionality that we added. This wasn't the easiest thing to do a couple releases ago, but excuse me. This wasn't the easiest thing to do a couple releases ago, but we've had a lot of interest from our automated driving customers who are using NVIDIA GPUs and things like that. Embedded NVIDIA GPUs. They aren't using the Jetsons. They're using something called the Drive PX, which is a more sophisticated controller. But I know a lot of teams. The NVIDIA Jetsons are very popular with y'all. Y'all can now generate CUDA-enabled ROS and ROS2 nodes directly from MATLAB. So if you've got a fancy deep learning network that's doing your detections for you, you can essentially generate CUDA code from that and deploy it as a remote node onto an NVIDIA onto an NVIDIA board. So whether it's the Gazebo, the Jetsons, what have you, as well as if you want to do it for like an NVIDIA Quadro, which is more of a laptop GPU, you can do that as well. Okay. Same thing works from Simulink as well. So if you've got, over the last couple of releases, we've added deep learning inference functionality into Simulink, so you can train a network in MATLAB and then stick it into a Simulink model. This again wasn't possible at least a year or so ago, but stick the deep learning network in there, and then you can generate a CUDA node for it to deploy to your network or to deploy to your NVIDIA boards. Okay. These are some examples that use this advanced YOLO V2 functionality, or shows you how to walks you through the steps to generate code. These are a little advanced, so we actually have a training on code generation. So I highly recommend, before trying to generate a node, at least go and take a look at a couple of those videos just to understand how MATLAB generates code, because there's a common misconception that whenever you generate code with MATLAB, you don't have access to the source code. You very much do. Like, you can open up that code in an IDE and edit it. We don't recommend that you do that, because the product that generates code from these from your files is that code is essentially optimized for embedded systems. So it's highly unlikely that you might be able to make it quicker. We have a lot of our customers around the world that use that same workflow to generate code for their production system. So, but that being said, there may be an opportunity where you are just generating code for a particular algorithm because MATLAB has a good algorithm for that particular use case, but then you want to generate code and integrate it somewhere else with another C++ code base. So that is a time when you might want to actually start looking at the generated code and play around with that. But as far as our recommendation, and Mathworks, the recommendation for this is always make whatever edits you want to make in the Simulink model or the MATLAB file, and then just generate code. Just keep regenerating code, because that way we give you the guarantee that as long as your MATLAB code is working, whatever's generated will perform in the same way. Okay, but these are some examples. Again, they're all in the ROS toolbox, so you can take a look at them for the documentation, or once I send the slides over, take a look at it at that point. Okay, so more examples on how to create a ROS control plugin. If you're working with UAVs, there's you can generate a UAV waypoint follower. There's an example for that as well. As well as if you're trying to do some more complex deep learning algorithms, we've got some examples for that as well. So let's take a look at some application examples. Again, these are all in the product, but the sign following robot with ROS in MATLAB example is really nice if you're new to robotics and trying to understand the way ROS works. At least get familiar with what the messages look like. What do you need to do? Because the messages essentially come in as strings. So there's some parsing that needs to happen before that string data is converted into actionable MATLAB data types, right? So that's a really good example to take a look at if you're new to MATLAB and robotics and ROS and you just want to figure things out. You should just be able to spawn this up from your MATLAB instance. So you shouldn't need any additional tools for that, except for a virtual machine, which are usually pretty free. If you're interested in something more complicated, we've got an automated parking valet example with ROS. So essentially, what you see is a true power of the decentralized nature of ROS, right? So you've got a planning node, a control node, a sensor acquisition node, and that model is set up that way, where everything's broken up and you generate, the smaller nodes too. So it'll give you an idea on how to architect your system when you're actually building your own robots. And there's also that ROS node for UAV waypoint followers. So if you're thinking about an SUAS or one of the RoboNation competitions that needs to fly a UAV, that may be something that you want to check out. And if you have any questions, please feel free to reach out to us. We're happy to help. So let's do a quick summary so we can end and take some questions. So in terms of what major ROS functionality looks like in both MATLAB and Simulink, this is a good sort of lay of the land. As you can see, our ROS support is pretty advanced. We've gotten to CUDA ROS node generation. We are catching up on the ROS2 side. Remember, ROS2 is a newer product. We support ROS Noetic for ROS, which is I believe their last distribution. And then for ROS2, we're supporting ROS2 Foxy. But then there's also the ability for you to switch your DDS communication system. And there's an example on that. So if you take a look at the documentation, depending on what you're doing, the DDS actually makes a pretty big difference with ROS2. So in terms of performance, so we have the ability to switch what DDS you're using, and there's an example of that in the documentation that you can take a look at. But we don't have support for ROS2 actions yet, but we're hoping that that'll happen soon. But custom messages, ROS-back reading, node generation, all that, we're pretty much on par with both ROS and ROS2. So as you can see, this is the ROS toolbox. This is a list of all our demos that are available in there. I personally love just taking the demos and trying it because I feel like I always learn something new whenever I open them. But that's, in my opinion, that's the best way to start learning MATLAB, is just open up a demo and try to break it and then try to fix it after that. But there's a whole host of demos for a variety of different use cases that you can take a look at. There's also some training available, a lot of complementary training available, especially if you're new to MATLAB. We're trying to put together, hopefully we'll have something in the next few months, but we're trying to put together a learning path for robotics. So you're essentially able to say, okay, I'm a beginner, this is where I start, or I'm a little more intermediate. And hopefully we should have that available soon. But there are a number of complementary on-ramps that you can take a look at. The on-ramps are all free, they're all online. You don't have to have MATLAB downloaded for that. Excuse me. We've also got student competition tutorials and videos. The idea with this is we try to create videos that are more relevant to what y'all are doing. So we've got a number of robotics videos that talk about things that at RoboNation you need to do, things like training networks, training neural networks, labeling ground truth. I know that's typically a big problem at RoboNation competitions, but we've got a lot of videos that walk you through that, as well as code that you can download and take it and get started. We just launched these new MATLAB and Simulink ROS tutorials. They're on GitHub. I believe there are like 9 tutorials. And you can use that to just absolutely get started with if you've never used ROS before, that's a good place for you to start, start and get familiar with what ROS is. And then we've got a blog as well. It's called the Racing Lounge blog, now the Student Lounge blog. I have to say, if you all have anything cool to write about, want to be published on our website, please reach out to me, and we'd be happy to get you to write a blog for us. But yeah, we, as you all know, we've been offering complimentary licenses to all RoboNation students. So if y'all these licenses have essentially every product that you'd ever need to use MATLAB and Simulink for robotics. So I know a lot of schools have campus-wide licenses. Sometimes that does not have all the product, depending on which school you're at. So if you ever feel like you don't have a particular product, we have you can request a software from us. All that I ask is that just have one person in your team do that, and then we'll essentially send you information on how everyone in your team can get access to those licenses after the fact. We've also got an email address if you have a question, roboticsarena@mathworks.com. We also have a Facebook group where we post a lot of these examples and things like that. So and there's usually a lot of good discussion going on over there. So there are places that you can reach out to us at. Yeah, if you have any questions, we're here to help. We've got a team of dedicated engineers for students. So we're not going to help you with your homework, but if you try to build a cool robot, we'll try and help you. But yeah, thank you for taking the time to join us for lunch today. If you have any questions, now's a good time. I see a couple of questions in the chat. Would like to know if ROS Melodic is support. I believe ROS Melodic is, but let me just take a look real quick, and I'll be able to confirm that for you right now.
Hi there. Are you giving out MATLAB and Simulink software for free?
Yes, sir.
Cool, because I thought you needed to pay for it.
Well, otherwise, yes. But if you're taking part in the competition, it is it is free. We can send you a link to how you can get that.
I'm new to ROS too, and I've been using the Construct website to
Okay.
get started.
Yeah. 1 second while this link loads. So I'm gonna. So just send you a link to the licenses. I just confirmed that ROS Melodic is supported. Yeah, it is. But if you have any trouble with that, just reach out to us. Oh, the other thing is, if you're on the student competition license, you actually have access to tech support. So your campus licenses typically do not have access. So if you cannot call up tech support, they will not be able to help you. But if you're on a student competition license, you can talk to our engineers and tech support, and they'll be able to help you with some of the more complicated stuff that you're doing. So take advantage of that. That's a lot of our customers use that. Like, we essentially our tech support team is our new engineers that are just hired to the company. And that's how they spend their time learning the products, is by helping our customers out. So there are real engineers sitting on the other end that can help you out with any questions that you'll have. Okay. Justin says we can all label a lot less if we share our label data. This is very true, but then that also makes it not a competition, because a lot of teams will not label any data then. But we've got an automatic labeler app, a ground truth labeler app for both LiDAR, and so LiDAR as in 3D point clouds, as well as images and videos that you can use. And you can introduce things like automated, automation algorithms and stuff for that. So it's, yeah. I believe there was 1 year at RoboSub where I showed that to a team, and they essentially trained a network overnight, because they were spending hours, and multiple people spending multiple hours trying to label networks. But then we showed them the automated labeling feature, and they were essentially able to train a network overnight, because they didn't have to sit and manually label image frames. So very useful. Regarding the free license, is it provided only for those? Yes. So the license agreement is that we give out free licenses for the purpose of the competition, right? So as long as you're working on stuff that's related to the competition, you're free to use that license.
Connell, I'm just going to pop in really quickly. So
yes,
RoboNation offers a few links to licenses for different software. So I'm going to pop in our RoboNation link as well. He provided the one direct Mathworks, and you can find information about SolidWorks and Autodesk as well.
Yep.
These softwares that are provided to people that are participating in our RoboNation competitions. Yeah, so you can find more information there.
This is the first time I'm hearing about this competition. What do you guys what's the competition for? Like, is it like a battle bot competition, or like should do something?
So RoboNation actually has 9 different programs for students from elementary school through postgraduate school. So we've got autonomous competitions that include RoboBoat, RoboSub, and RobotX. So these are competitions that the vessels fully drive themselves. We also have a number of other affiliate programs. So we have a ground vehicle competition, an air vehicle competition, as well as a drone competition. And then for younger students that are in middle school, high school, they can participate in our Sea Perch program, which is an ROV vehicle that you can use under the water. So it's a submarine type vehicle. So each of those programs, if you participate in the competitions, you can get a part of the Mathworks license, but more so than that, they're an amazing opportunity to meet other students that are interested in things just like you, as well as have an opportunity to test out your skills in robotics. I'll pop in the link more information about RoboNation so you can see each of those programs in the chat.
Yeah, I want to find out how I could participate in this. Like, I don't have a group or a team or anything.
What age group are you a part of?
I'm 27.
Okay, so if you're a part of a university, you can either get a part of one of our university programs. And Juliana, I don't know if you're on the call right now, if you want to pop in and share just a little bit about our autonomy programs for university students. She might not be on the call right now, but if you email at the end of this presentation, we'll have an email list and we can get you connected to our autonomy programs, and they can help you find out more information about joining a team either at your university or getting a team started.
Okay.
Perfect. I was just going to say, this is Janelle from RoboNation. I was going to say, you can also start your own team. What area are you in, Abel?
Well, right, I'm a Cal State Fullerton student, but I'm
Nice.
not going back to school till next year.
Okay.
So
Okay. We do have provisions for fully matriculated students, non-full-time students to participate in teams. So I believe Fullerton used to have a RoboSub team. I'm not sure if they have an active team right now. But if you reach out to that email address that Laverne put in the chat, they can help you to link up with the team that might be regionally in your area. There's also opportunities for you to participate online in a lot of ways and kind of use the opportunity to get started and use Mathworks and learn about some of these things while you're finding a team that you can join.
okay, yeah, I'm looking for a team right now. I still have classes on campus,
Perfect.
but I'm not fully
Oh, cool.
enrolled.
Okay. Yeah, no, that's great. We'll reach out to autonomy@robonation.org, and our folks will help you get linked or try to find a team for you to join.
All right.
Kind of give you some ideas. Think about what kind of vehicles you might be interested in. As Alicia mentioned, we have a lot of different modalities. And if there's one that you're particularly interested, that's great. Otherwise, you can focus more geographically and just, join a team that might be an air vehicle team or might be a sub team. But if you have a particular area of interest, maritime or ground or aerial, then we can start there too. So you might include some of that information when you email the autonomy@RoboNation.
All right. Yeah, right now I'm working on a Raspberry Pi smart car by myself.
Cool.
So yeah.
Cool.
Something started.
That's awesome. There's a ton of ways to test and learn, and I'm sure Connell will. Connell did a vehicle competition. It was a much larger vehicle, right, Connell?
Yeah, formula student when I was
There you go.
when I was in school. That was 10 years ago. I can't imagine how long. I'm getting old.
So
right.
we'll get you information, Abel.
Okay, thank you.
Yeah, thank you.
Does anyone have any other questions? If not, we can call it. But yeah, please feel free to reach out. I know I'll be back at some point to do another one. I don't quite remember the date, but I know it's in the next month or so. So yeah, hope to see you all again. And if you have any questions, please reach out to us.
Thank you guys. We really enjoyed having you today. Have a good one.